Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study and solve some of the problems on elastic constants. The elastic constants are Poisson's ratio, Young's modulus, modulus of rigidity, and bulk modulus. These four comes under the category of elastic constants. Let us start a problem. How to find out the Poisson's ratio and modulus of elasticity for the given data. A concrete cylinder of diameter 150 millimeter and length is 300 millimeters when subjected to axial compressive load of 240 kilonewtons resulted in an increase of diameter by 0.127 millimeter and a decrease in length of 0.28 millimeter. We have to calculate the Poisson's ratio mu or 1 by m. The second objective is modulus of elasticity E. The given data here it is the diameter of the cylinder equal to 150 millimeter and length L equal to 300 millimeters. When subjected to axial compressive load, that P equal to 240 kilonewtons, that is 240 into 10 cube newtons. It is an increase in diameter. It is increase in diameter and decrease in length. Increase in diameter delta D that equal to 0.127 millimeter and decrease in length delta L is 0.28 millimeters. The modulus of elasticity is E equal to stress by strain. What is the sigma equal to? E equal to stress by strain, that is sigma by epsilon. What is sigma is P by A and epsilon is delta L by L. Now this is the data is given here. Decrease in length, diameter is 150 millimeters, delta D 0.2127, that is increase in diameter. Why it is increases diameter? When the load, it is the compressive load is acting. Because of the compressive load, there is a decrease in diameter and decrease in length and increase in diameter. The length will be decreased, that is delta L is decreased. The delta L here decrease in length, the delta L is 0.1 to 0.28 millimeters and the diameter will be increased because of the compressive load. Whereas in the case of the tensile load, when the tensile load is applied, then the diameter decreases and the length increases. Now here the linear strain, there are two types of strains here to calculate the Poisson's ratio. The Poisson's ratio, that is mu equal to lateral strain by linear strain. Lateral strain by linear strain. What is the lateral strain here? The lateral strain is delta D by D. Linear strain equal to delta L by L. The linear strain delta L by L, that is delta L here it is 0.28 and L is 300 millimeters. Then linear strain is 0.000933. And the lateral strain, it is in normal to the linear strain, that is delta D by D. The delta D by D, delta D is 0.127 millimeters and D is 150 millimeters. This delta D by D, that is 0.127 by 150, that is 0.00846. So this is the value of linear strain. The value of the linear strain is 0.000933 and the lateral strain is 0.000846. And the ratio of lateral strain to linear strain, that is mu, Poisson's ratio mu equal to, substitute here the lateral strain and linear strain values, then the Poisson's ratio is 0.907. Then the next objective is calculating the modulus of elasticity. The modulus of elasticity E equal to stress by strain. Here the strain is the linear strain. It is not lateral strain. Why? Because the strain which is applied in the direction of the load, that strain is the linear strain. So here stress by linear strain, stress in the direction of the load, that is P by A, linear strain delta L by L. Here it is P is 240 kilonewtons and A is pi d square by 4. A is the area of cross section, pi d square by 4. Then substitute here pi by 4 into d square. What is the d? 150 millimeters. That is in terms of meters, that is 0.15 meters. 240 by pi by 4 times 0.15 square. And delta L, the delta L it is obtained here, it is delta L by L is obtained as delta L by L 0.00933 or delta L by L in terms of meters 0.0028 millimeters, 0.0028 by L. L is in terms of meters 0.3. So substitute over here, then the obtained values 240 into 4 times 0.3 by pi times 0.15 square times 0.0028. The observed value is 14.55 into 10 power 6 kilonewton per square meter. Why kilonewton per square meter? Because here it is stress is in the units of kilonewtons and area is in terms of square meters and delta L by L it is meters by meters. Thus we obtained as 14.55 giganewton per square meter. Now this is the Young's modulus. The value of the Young's modulus capital E equal to 14.55 Gn by meter square and the Poisson's ratio is 0.907. Suppose if it is applied the tensile load, then the diameter decreases and the length increases. So then the diameter becomes positive, then the diameter, the value of decreasing diameter, that becomes negative and the length becomes positive. This is the problem for when the load is applied under compressive load. Next, the problem number 2. Here for a given material, the modulus of elasticity is 110 giganewton per square meter. Shear modulus, that is modulus of rigidity, and C equal to 42 giganewton per square meter. We have to find out the bulk modulus, find bulk modulus and lateral contraction of a round bar of 37.5 millimeters diameter and 2.44 meters length when stretched 2.5 millimeters. The length here, where the length of the bar is 2.4 meters. When it is stretched, that is delta L is 2.5 millimeters. When stretched 2.5 millimeters, that is delta L. Convert into meters, 2.5 into 10 power minus 3, that is 0.0025 meters. And the diameter of the round bar, is 37.5 millimeters. Convert into meters, 37.5 into 10 power minus 3, that is 0.0375 meters. And shear modulus G, that is modulus of rigidity, that is 42 giganewton per square meter, that is 42 into 10 power 9 Newton per square meter. The modulus of elasticity 1110 10 power 9 Newton per square meter. Now we know the relations. What are the objectives you have to find out? Find the bulk modulus and lateral contraction. So this lateral contraction and linear, we have to find out the delta D and also bulk modulus K. So we need to know the relation between ECM. From that we can find out the Poisson's ratio. Now here bulk modulus and EC, the bulk modulus, that is E, we have to find out bulk modulus, that is K. We know the relation between EC mu, that is E equal to 2C times 1 plus 1 by m. E, substitute here 110 giganewtons, convert into Newton, that is 110 into 10 power 9 Newton per square meter. 2 times C, 42 into 10 power 9, 1 plus 1 by m. From this here, m equal to 3.22 or 1 by m equal to 0.31. This 1 by m is nothing but Poisson's ratio, that is Poisson's ratio is 0.31. Now m equal to 1 by 0.31, that is 3.22. So there is another relation, E equal to me by 3 times m minus 2. Then E equal to, that is K equal to me by 3 times m minus 2. Then substitute over here m value, E value, then bulk modulus can be calculated. Then K equal to me by 3 times m minus 2, that is then 3.22 times E, 110 into 10 power 9 Newton per meter square, 3 times m, 3.22 minus 2. Then the values observed, bulk modulus equal to 96.77 giganewton per square meter. This is the bulk modulus. We want lateral contraction. We know the Poisson's ratio, mu equal to lateral strain by linear strain. Lateral strain by linear strain. This lateral strain is delta D by D. Linear strain is delta L by L. So, linear or longitudinal strain. Linear or longitudinal strain. Delta, this linear strain or longitudinal strain, delta L by L. We know the Poisson's ratio, that is 1 by m or mu, that is 0.31. 0.31. 0.31 equal to lateral strain delta D by D by delta L by L. From this we have to calculate what is delta D, that is the lateral contraction. So delta L by L, delta D by D equal to 0.31 times delta L by L, that is delta L by L equal to 0.00104. Now D we know that now known value of the D is 37.5 millimeters. Then delta D equal to 0.31 times 0.00104 times, that is 37.5, that is 0.0121 millimeters. This is the lateral contraction. So how we found out lateral contraction? Let us summarize the problem, how to solve the problem. The summary of the problem is that here the known values are modulus of rigidity, modulus of elasticity, and diameter of the bar, and the length and change in length of the bar. So in order to find out the lateral contraction, that is delta D, comes from the formula of Poisson's ratio. The Poisson's ratio formula is lateral strain by linear strain. Linear strain formula is delta L by L. Lateral strain formula is delta D by D. So we have to find out delta D. For that one, there is another unknown is there, that is the Poisson's ratio mu. This Poisson's ratio is calculated between the relation between EC mu values. From that E modulus of velocity, from that m calculated, that 1 by m is the Poisson's ratio 0.31. After knowing the Poisson's ratio, the unknown is delta D. So from delta D, that is a decrease in diameter, delta D by D is calculated from the formula of Poisson's ratio. There is another, that is bulk modulus we need. Bulk modulus relationship between K, E, mu relationship. What is the K, mu relationship? This is the K, mu relationship. From this we calculated the bulk modulus of elasticity. So in this bulk modulus of elasticity is calculated as 96.77 giganewton per square meter, and the Poisson's ratio is 0.31. from the decrease in diameter is lateral contraction, that is delta D is 0.0121 millimeters. Thus we have to calculate this lateral contraction and the bulk modulus by using the formula of Poisson's ratio and the formula which is having relation between ECM and also another formula is called between E and K formula. From that we calculated. Bulk modulus can also be calculated if we know the relationship, that is E equal to bulk modulus can also be calculated from another formula, E equal to 9 kc by 3k plus c. The known values are E and modulus of rigidity. The unknown value is bulk modulus. This bulk modulus K can be calculated by using this formula, E equal to 9 kc by 3k plus c. By using this formula, bulk modulus can also be calculated directly. The third problem, very important and important model for understanding the Poisson's ratios and elastic modulus we can calculate from this data. And this problem also covers to all elastic constants can be calculated by using this data. Here the following data related to a bar subjected to tensile test. Subjected to a tensile test, and the diameter of the bar, that is 30 millimeters, component is tensile load applied is 54 kilonewtons, the gauge length L equal to 300 millimeters, and the extension of the bar, that is delta L, is 0.112 millimeters. Change in diameter, that is a decrease in diameter, that is 0.00366 millimeters. We have to find out Poisson's ratio mu and the values of three moduli, that is modulus of elasticity, modulus of rigidity, and bulk modulus. These are the four objectives are to be found by using this data. Now here we know the Poisson's ratio. The Poisson's ratio formula is lateral strain by linear strain. What is the lateral strain? That is delta L. Lateral strain is delta D by D, and the linear strain or longitudinal strain is delta L by L. So one more thing is that we know the stress. The stress is the sigma equal to P by A. That is load per area. The tensile load is 54 kilonewtons. Here substitute 54 kilonewtons and area is pi by 4 d square, where d is the diameter. Convert millimeters into meters, that is pi by 4 d square. 54 by pi by 4 times d square, 0.03 square. Here it is in kilonewtons and here it is meters. The stress value comes as kilonewton per meter square. That is 76394 kilonewton per meter square. So that is 76.394 into 10 cube into kilonewton, that is mega newton per meter square. That is 76.4 mega newton per meter square. Then the linear strain equal to delta L by L. We know that delta L, the value of delta is 0.112 millimeters extension, and L is 30 millimeters, and L 300 millimeters gauge length. Then if you substitute here, that is 3.73 into 10 power minus 4. And linear strain value is delta D by D. The delta D is 0.00366, and again here diameter is 30 millimeters, that is 1.22 into 10 power minus 4. Substitute these values, known values, in the formula of Poisson's ratio, that is mu equal to lateral strain by linear strain. The lateral strain is 1.22 into 10 power minus 4 by linear strain 3.73 into 10 power minus 4. This 1.22 by 3.73, that is 0.327. So 10 power 4, 10 power minus 4, 10 power minus 4 get cancelled. This 1.22 by 3.73, that is we have calculated as 0.327. The next we have to find out three elastic constants remaining: modulus of elasticity, modulus of rigidity, and bulk modulus. The formula for relationship between EC is that EC and Poisson's ratio E equal to 2C times 1 plus 1 by M. We know the modulus of E equal to, we need E. How it comes? E value, E equal to stress by linear strain. What is the stress value calculated here? It is 76.4 meganewton per square meter, and the linear strain is 3.73 into 10 power minus 4. That is stress 76.4 meganewton by 3.73 into 10 power minus 4. It is in meganewton per square meter. It is meter by meter. So the value comes, it is the units for the output calculated value is meganewton per square meter. That is 2.05 into 10 power 5 meganewton per square meter. This is modulus of elasticity. One object was calculated. Then also E equal, we want to find out modulus of rigidity. The relation between, then we have to search the formula which is having a relation between modulus of elasticity and modulus of rigidity and also Poisson's ratio. That formula is E equal to 2C times 1 plus 1 by M. This 1 plus 1 by M, unknown value is C. Then C equal to E by 2 times 1 plus 1 by M. The formula, this formula is converted into, in terms of the output is modulus of rigidity, that C equal to E by 2 times 1 plus 1 by M. Then E by, what is the E value? 2.05 into 10 power 5. 2 times 1 plus 1 by M, that is 0.327. That is the Poisson's ratio we calculated as 0.327. So 0.327, after substitution all the known values, the unknown can be calculated. That is modulus of rigidity, that is 0.77 into 10 power 5 meganewton per square meter. Next, the third relation, we know E and we know C. We have to find out K. The another relation is, one of the relation E equal to 3K times 1 minus 2 by M. So the relation here, we want the output objective here, it is K, bulk modulus. Then this formula is transformed into the required formula, that K equal to E by 3 times 1 minus 2 by M. And then E value substitute here 2.05 into 10 power 5, that is meganewton per square meter, 3 times 1 minus 2 times 1 by M, that is 0.327. The output value is observed 1.97 into 10 power 5 meganewton per square meter. There is another method we can calculate this bulk modulus after knowing E and C values. After knowing E and C are known values, how to find out the bulk modulus? E equal to 9 kc by 3 times 3k plus C. If you substitute E equal to 9 kc by 3k plus C, from this we need K value. How it comes? E into 3k plus C equal to 9 kc. That is 3ke plus EC equal to 9 kc. 3 times from, make it 9 kc minus 3 ke equal to EC. From this make it common, k common, 9c minus 3e equal to EC. From this k equal to EC by 9c minus 3e. So the bulk modulus can be calculated if you substitute the known values of modulus of elasticity and modulus of rigidity in this formula, then the value can also, the value comes, it is same as the formula it is calculated here, that is Ek equal to E by 3 times 1 minus 2 by m, that is 1.7 into 10 power 5 meganewton per square meter. This is one method. And the another method to calculate bulk modulus is the formula. It is another formula to calculate bulk modulus of elasticity. If we know the Young's modulus and modulus of rigidity. So after knowing these two values, if we substitute in this formula, we can directly calculate bulk modulus of elasticity. Okay, next. Let me summarize. In this class, we have learned to calculate what is Poisson's ratio, and calculation of decrement in length delta D, and the third is Poisson modulus, calculation of modulus of elasticity, modulus of rigidity, and bulk modulus K. So Poisson's ratio formula, the formulae here were used. Poisson's ratio mu r 1 by m equal to lateral strain by linear strain, and the relation between E, C and K, that is E equal to 9 kc by formulae E equal to 9 kc by 3k plus C. The relation between another formula E equal to 2c times 1 plus 1 by m, and another formula E equal to 3k times 1 minus 2 by m. So these are four formulae were used to calculate Poisson's ratio, modulus of elasticity, bulk modulus, and modulus of rigidity. Suppose in problems, if the tensile load is applied on the bar, if the tensile load is applied on the bar, when the tensile load is applied on the bar, after applying the load, the deformation becomes positive. And diameter deformation along the applied load is positive, and lateral strain are decreasing, the diameter is decreased. When compressive load is applied on the bar, then decrement takes place, the deformation, decrement, that means a decrease in length, that means deformation becomes negative, and increase in diameter takes place, increasing in diameter takes place when the compressive load is applied. When the tensile load is applied, length increases, diameter decreases. When the compressive load is applied, length decreases and the diameter of the cross section increases. So that's why when the compressive load is applied, increase in diameter, decrease in length takes place. When the tensile load is applied, increase in length, decrease in diameter takes place. That's why in this problem, the way we solve here, the data was given. Here, decrease in length, it becomes delta L becomes negative. Increase in diameter, it is positive considered here. Why the load applied here, it is axial compressive load. When the axial compressive load comes, or the axial compressive load acted on the component or on the specimen, decrease in length takes place, increase in diameter takes place. That is the interpretation one can perceive from the data of a given problem. So Poisson's ratio, I would like to discuss about Poisson's ratios in the problems. Poisson's ratio is always less than 1. Is always less than 1. Why? Because Poisson's ratio equal to lateral strain by linear strain. The lateral strain value is always is always less than linear strain. Okay, so that's why here Poisson's ratio comes always less than 1. It never become more than 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.